When Elon Musk first announced plans to build the largest rocket in human history, skeptics said it would take decades. SpaceX proved them wrong. Not only did they get Starship off the ground in just a few years, but they've now achieved something remarkable, launching 2 successful flights just 1 month apart. Flight 6 shattered records and demonstrated SpaceX's relentless pace of innovation. Now, as we prepare for Flight 7, NASA has just revealed the official launch date that could mark the next giant leap in spacecraft development. Welcome to Elon Musk 24 Hours, your source for the latest breakthrough developments in space exploration. Let's dive right in. In the wake of Flight 6, the atmosphere at SpaceX's Starbase was electric. Engineers huddled around monitors, analyzing data from what appeared to be both a triumph and a wake-up call. While celebration filled the air after achieving the fastest turnaround between flights in Starship's history, a deeper story was unfolding behind the scenes. The Super Heavy booster's return phase revealed the first dramatic twist. As millions watched live, the massive rocket, taller than the Statue of Liberty, began its descent toward the Gulf of Mexico rather than attempting the planned tower catch. In mission control, a tense silence fell as controllers detected a critical communication misalignment between the booster and launch tower systems. Years of preparation had led to this moment, and now they faced a split-second decision that would echo through the program's future. Flight control, switching to contingency protocol alpha, came the calm voice over the comm system. The booster executed a perfect splashdown, creating a spectacular water landing that, while safe, highlighted the razor-thin margins between success and failure in space exploration. In the following days, as teams retrieved data recorders from the Gulf, they discovered something unexpected. The communication issue stemmed from a previously unknown interaction between the tower's advanced guidance systems and the Gulf Coast's unique weather patterns. The drama didn't end there. The Starship upper stage, carrying the hopes of future Mars missions, completed its primary objectives flawlessly. As it began its descent toward the Indian Ocean, everything seemed nominal. Then, in a heart-stopping moment, radar contact was lost. When visual confirmation finally came through, the spacecraft had exploded on impact, a reminder of the brutal physics involved in bringing a vehicle of this size back from orbital velocities. But at SpaceX, setbacks fuel innovation. Deep within the company's development facilities, a revolutionary response was already taking shape. Starship version 2. Engineers worked through countless nights driven by Elon Musk's ambitious vision and the lessons learned from each flight. The new design wasn't just an upgrade, it represented a fundamental rethinking of how a spacecraft this massive could be made truly reusable. The heart of this transformation lies in its heat shield system. Traditional tiles, while effective, couldn't meet the extreme demands of Starship's mission profile. SpaceX's materials science team, after months of secretive development, created something extraordinary, a new generation of thermal protection tiles that could withstand temperatures exceeding those at the surface of the sun. Each tile underwent testing that simulated the harshest conditions imaginable, from extreme temperature cycling to hypervelocity impact resistance. NASA's announcement of the January 11, 2025 launch date for Flight 7 sent ripples through the space community. But behind this date lies an untold story of preparation and innovation. Ship 33, the V2 prototype, emerged from SpaceX's assembly bay in a record-breaking 41 days, a feat that had veterans of the space industry questioning their long-held assumptions about spacecraft manufacturing. The decision between boosters 14 and 15 has become more than just a technical choice. It represents 2 competing philosophies about the future of space exploration. Booster 14, battle-tested and ready for static fire testing, embodies the fly early, fly often approach that has served SpaceX well. Booster 15, still under development, promises to push the boundaries of what's possible with its advanced systems and closer alignment to the V2 vision. The real revolution, however, becomes clear when examining the Raptor engine evolution. The projected thrust of 8,240 tons isn't just a number. It represents enough power to lift the equivalent of 4.5 Eiffel Towers off the ground. The Raptor 3 engines, necessary for achieving this unprecedented power, required solving engineering challenges that many considered impossible just years ago. Each engine component undergoes testing that would destroy lesser machines, ensuring reliability in the harshest conditions space can offer. Meanwhile, the Falcon 9's journey to its 400th flight tells an equally compelling story of persistence and innovation. On that historic November day, as booster B-1075 made its 15th successful landing on the Of Course I Still Love You drone ship, the team at Mission Control reflected on how far they'd come. From their first recovery attempts ending in spectacular failures to now routinely landing rockets on floating platforms, SpaceX had fundamentally changed what was possible in spaceflight. The numbers barely capture the magnitude of this achievement. Breaking the Soviet Union's 1980 record wasn't just about quantity, it represented a fundamental shift in how humanity accesses space. Each of the 115 launches in 2024 carried not just payloads but the dreams of global connectivity through Starlink, scientific discovery, and commercial opportunity. The reliability rate exceeding 99% across hundreds of missions wasn't achieved through cautious increments, but through bold innovation tempered by rigorous testing. Looking toward Flight 7, SpaceX faces its greatest challenge yet. The mission will test not just the hardware, but the fundamental premise that space travel can become as routine as air travel. Each modification to the heat shield, each adjustment to the flight software, each improvement to the landing systems brings us closer to that future. The combination of Starship's revolutionary design and Falcon 9's proven reliability has created a momentum that's reshaping our relationship with space. As teams prepare for the January launch, they carry with them lessons learned from every success and failure. The path to Flight 7 isn't just about reaching orbit, it's about proving that humanity's future among the stars is closer than we ever imagined. In the words of a veteran SpaceX engineer, we're not just building a rocket, we're building the foundation for becoming a multi-planetary species. The story of SpaceX's journey continues to unfold, marked by moments of breathtaking success and educational failure, each bringing us closer to a future where the impossible becomes routine. As we approach Flight 7, one thing remains clear. In the race to revolutionize space travel, every launch, every test, and every innovation brings us one step closer to the stars. As we stand on the brink of Flight 7, SpaceX's journey reminds us that the path to the stars isn't just about technological achievement, it's about human perseverance, innovation, and the courage to learn from both success and failure. From the rapid development of Starship to the unprecedented reliability of Falcon 9, each milestone writes a new chapter in humanity's space exploration story. The upcoming January launch isn't just another test flight, it represents our collective step toward becoming a multiplanetary species. As Ship 33 stands ready with its advanced heat shield and the potential of Raptor 3 engines, we're witnessing history in the making. The choice between boosters 14 and 15 will shape not just this mission, but the future of space travel itself. SpaceX's achievements in 2024, from breaking launch records to perfecting reusability, prove that what once seemed impossible is now within our reach. As we anticipate Flight 7, remember that you're not just watching space history unfold, you're part of the journey. Stay updated on this historic mission and all of SpaceX's groundbreaking developments by subscribing to Elon Musk 24 Hours. Hit that like button if you're excited about the future of space exploration and share your thoughts about Flight 7's upcoming launch in the comments below. Don't forget to share this video with fellow space enthusiasts who share our passion for innovation and exploration. See you in our next video, where we'll continue bringing you the latest developments in humanity's greatest adventure. This is Elon Musk 24 Hours, your window to the future of space exploration. The space industry is witnessing a dramatic turning point. While SpaceX has long dominated the commercial launch market, a formidable challenger is emerging from an unexpected corner. Rocket Lab, already the second most active U.S. aerospace company, is about to unveil their most ambitious project yet, the Neutron rocket. This isn't just another rocket. With its innovative carbon fiber construction, groundbreaking 3D printed components, and a revolutionary reusable fairing system, Neutron represents a fresh approach to medium-lift launch vehicles. And with a development cost of just $300 million, a fraction of its competitors, it's positioning itself as a serious contender in the U.S. Space Force's National Security Space Launch Program. Meanwhile, SpaceX continues pushing boundaries, achieving their 400th successful Falcon launch and maintaining their critical role in ISS operations. But recent technical challenges have caught NASA's attention, raising important questions about the balance between rapid progress and operational safety. From Rocket Lab's bold entrance into the medium-lift market to SpaceX's latest milestones and challenges, we're exploring the evolving dynamics of America's space race. Welcome to Elon Musk 24 Hours. Let's dive right in. Rocket Lab's rise from a small launch provider to a potential SpaceX competitor is nothing short of remarkable. Their Electron rocket has already achieved an impressive milestone, 10 successful launches in a single year. This achievement becomes even more significant when compared to the slower progress of industry veterans like ULA and Blue Origin. But the real game changer is Neutron. This next-generation rocket represents more than just an upgrade. It's Rocket Lab's bold declaration that they're ready to compete in the big leagues. The company's innovative approach to manufacturing sets Neutron apart in several key ways. First, there's the extensive use of 3D printing technology. While other companies have experimented with additive manufacturing, Rocket Lab has made it central to Neutron's production. This strategy significantly reduces both manufacturing complexities and production time, allowing them to scale up operations faster than traditional methods would allow. Then there's the revolutionary carbon fiber construction. Unlike SpaceX's stainless steel approach with Starship, Neutron's lightweight carbon fiber design prioritizes thrust to mass efficiency. While this material might be less durable during re-entry, the weight savings translate directly into increased payload capacity, a crucial advantage in the competitive launch market. Perhaps the most innovative feature is Neutron's unique fairing design. Unlike traditional fairings that separate and fall away during launch, Neutron's fairing remains attached to the rocket and partially opens like a flower to deploy payloads. This design isn't just visually striking, it eliminates the need for fairing recovery operations and significantly reduces refurbishment time and costs. The speed of Neutron's development has been particularly impressive. In just 3 years since its announcement, Rocket Lab has already completed the first successful test of its Archimedes engine. This rapid progress stands in stark contrast to competitors like Blue Origin's New Glenn and ULA's Vulcan, both of which have faced significant delays despite longer development timelines. What makes this achievement even more remarkable is the budget. With an estimated development cost between $250 to $300 million, Neutron is being built at a fraction of what traditional aerospace companies spend on new rocket development. This cost-effective approach could revolutionize how the industry thinks about rocket development and production. The timing of Neutron's development couldn't be better. The U.S. Space Force's National Security Space Launch Program is actively seeking to expand its roster of launch providers. Current contractors include SpaceX, ULA, and Blue Origin, but the program's structure specifically encourages new competitors to challenge these established players.